Okay, good afternoon. Today's challenge is to make the central processing unit. Now, in the gaming PC that I've got in front of me, it's a mid-range Intel 64-bit processor. So it's an i5, and if you buy a particular processor, you have to make sure that it fits the right motherboard, because each processor has a very particular socket that it fits into. So do research that carefully. The central processing unit, its job is to fetch, decode and execute instructions. So it gets its instructions and its data from RAM. Remember, we made RAM last session, I think. This is the RAM. RAM stores data and instructions. Data is like your variables. It's like the Word documents that you're writing, and it's also like the 3D models that you're creating in Blender at the moment. The instructions is like your program code. That's the stuff that you write in Python or C or assembly or things like that. All of that, both data and instructions, are stored in your RAM. Oops, I don't want to do that. The motherboard connects everything together. So we want the processor to go into this socket here, the RAM to go into these sockets here, which I didn't finish modeling properly, and the graphics card to go in here, and there might be a slot as well to put your SSD in as well. Right, so let's get started with our CPU. Remember, you can watch down here to see which keys I'm pressing if I forget to say. So we start with the cube, S to scale, Z to scale in the Z axis, and that's pretty much going to be the size of our CPU. So the main focus of today is how do we get a two-dimensional texture onto a three-dimensional shape. So I've searched for a picture of a CPU, and I've got a picture that has both the front and the back. It makes it a little bit easier for us. If I try and save this, it will probably save it as a WebP. That's an image file format that Blender doesn't support. So let's copy it, put it into PowerPoint or Photoshop or Paint, it doesn't really matter which. Paste it in, and then right-click, Save as Picture, so that we've got a copy in here. I'm going to call this Intel i5. If it's an i3, it means it has less processing power than an i5, which has less processing power than an i7, has less processing power than an i9. The i9 is going to be the most expensive. You've also got AMD CPUs, which have a different kind of way of determining which is better. Generally speaking, the better the CPU, the faster it is, because it has more transistors. What are transistors? They're digital switches. It means it can process more instructions per second. Right, we need that image in here. How do we do that? We need a material. That's the materials tab down here. So far, we've done solid textures. So we can click on this white color and make it a green, a dark green. We won't see that color whilst it's in solid mode. We have to be in material mode at the top. So for RAM, that's all we did. We just changed individual vertices and individual face colors. I want it to look much more like this. So instead of just clicking on the color, we click on the blob to the left of it and choose image texture. We can now open an image texture, find a picture. I think I called it Intel i5. Sorry, all sorts of weird and wonderful things. iMedia logo, Intel i5, there it is. So it's there, but it's in the wrong place. So a quick introduction into all of the things that Blender can do. We won't be able to go through all of these in Game Dev Club. Today we're going to focus on UV editing. UV is another word for X and Y. We're used to, in maths lessons, drawing graphs that go across X and up and down Y, because Y rhymes with sky. But in 3 dimensions, we have Z. However, we've got a 2-dimensional image, and we can't use X and Y again, because that's confused with 3-dimensional space. We use U for X and Y. V for Y. How does that help? Well, we need to splat this 2-dimensional image over here. And notice, irritatingly, this is in material mode, UV editing has switched and you can't even see it. You've got to put your mouse up here and scroll down to get that's better. You got material mode back on. Material preview. Next, I want to select this face, and I'm currently in vertex mode. I need to press 3 on the keyboard to get face select mode working. Move your mouse over to the left-hand part of the screen and press A to select all. Now you can move this, and you'll notice the square on the left is the part of the screen that's displayed over here. So I'm going to press S to scale, SY to scale up in the Y-axis. And you can choose whether you want to have those notches in. I think that looks okay. And if you want, you can rotate it. I'm going to press R. And if you want to be precise, you can do R90 to rotate by 90 degrees. But if you do that, bear in mind, you're going to have to stretch in either X or Y. There we go. Nice. And I'm going to do the same for the bottom. So I click on the bottom face. A to select, G to grab, position it in the right place, scale it up. Sometimes you might have to do SY to scale in the Y-axis, and we're good. I'm not going to bother with the sides. You can focus on those if you want. The next thing, can we extrude this top bit? So I'm going to go back to the layout mode to make it a bit easier to see. Remember, tab to toggle edit mode or object mode. That's up here. I'm going to press tab, that's the button to the left of Q, to go into edit mode and select this face. If I extrude this upwards, it takes the whole of the space. I don't want to do that. Control Z. Instead, I'm going to go for inset faces. I get a circle here. I can click and drag on that circle. That's better. Until I get the kind of the size and shape. Now, it's not a perfect square. So I can do S and Y. No, wrong one. S and X. Oh, notice how that stretches and deforms the texture. I wonder if there's a way to prevent it from doing that. I'm sure I saw a YouTube tutorial that told me how to do it, but I've forgotten. It's annoying. So we might have to remap that. Let's try S, X. Make it about how it was. And then shift and click on this. Go back into UV editing. We've got more topology here. There we go. We might have to just... Can we move that upwards? G, Y. Ah, yeah, there we go. We can move that line. Click, shift click, G, Y. That's better. Good. Not essential if you don't get that bit right. But we've now got the topology, the shape of the vertices in the right place. We can click on this bit, E to extrude and pull it up. It doesn't look right because in the real world it's kind of chamfered a little bit. It's got a bevel. So I'm just going to press S to scale it in. And that's not terrible. If you really want to, you can flip it over and work on these bits here. So I'll show you how to do it. But you might decide it's too much effort. Let's see. Shift A to add. I'm going to add a cube. S to scale until it's nice and small. GZ to move up. S to scale. Need to position it in exactly the right place. GZ down there. There we go. SX. No, wrong one. SY. Is that in the right place? Oh, it's too fat. SZ. Squidge it down like that. Oops. GZ. GX. Right, we've got one of them. SY, GY. Let's go to UV editing and put the right part on. If we get that selected, A, G to grab, zoom in, scale it. Going very fast because most of you won't do this. There we go. S to scale. SY to stretch out like that. There we go. I mean, we don't need to do this. It's a pretty terrible texture at this resolution. Once we've got one, we should be able to copy it. However, I've only got one part here. If I shift D to duplicate, look, I've only got the top face. Escape, cancel, Control Z. New keyboard shortcut, Control L to select linked vertices. All of the vertices that are linked to it in its 3D shape are now selected. Really, really helpful. Shift D to duplicate. X to lock the duplicate in the X-axis. Shift D, X, click. Alright, Shift click, Shift click. Control L to select linked vertices. Shift D, Y. Shift D, Y. This time, I'm going to get all of these 3. Control L for linked vertices. Shift D, Y. And get all of them over there. Now, if you really wanted to, you could do it for all of the other surface mount components, but please bear in mind that that is going to sit in the motherboard and nobody's ever going to see them. So it might make you happy to model them, but the more vertices you have, the more work that your GPU, your graphics processor, is going to have to do to render it. So try and minimize the number of vertices you have. So that's it. That's our competition. See how much accuracy you can create on your CPU.